All right, guys, so today we're going to talk about complex numbers. And again, all of this or most of this should be review. So what I would like for you to do on your notes with your table partner, I want you to classify the following numbers. So we have 0, -1, 1/2, square root of 3, +2, 0.75, and 6 and pi. Okay, I would like for you to put these on the chart, and all of them start in the real number box. So we can put all of them up here: 0, -1, 1/2, 0.75, square root of 3, 2, 6, and pi. All right, so I'm going to give you about a minute, and I want you to trickle down from here. What numbers from the real number box go into irrational, what go into rational, and then trickle down from the rational. Okay? All right, I'm going to give you about a minute to go. All right, let's talk about where these numbers go. So you should have in the irrational number box the square root of 3. That's the only one, and pi. Excuse me, not the only one, 2. Okay, what makes these irrational? They are non-repeating, non-terminating decimals. So non-repeating, non-terminating, which means they don't stop, decimals when you punch them in on your calculator. Okay, so there's those two off the list. Now, the rest of those will fall into the rationals. So 6, 2, 0, -1, 1/2, and 0.75. Okay, all right, so the first category when we move from rational to integers, our fractions and our decimals drop off. So 6, 2, 0, -1. Okay. When we move from integers to whole numbers, our negatives drop off. So now we're down to 0, 6, and 2. And then we move from whole numbers to natural numbers, the 0 drops off. Natural numbers are also sometimes referred to as the counting numbers, because when you learn how to count, you don't start with 0. You start with 1, 2, 3, 4, 5. So those are the natural numbers. Okay? So I hope we remember that part from Algebra 1 and 2, and probably before that. So let's talk specifically about complex numbers. Okay, complex numbers are what happens when we have negatives under the radical. So we use I is the imaginary unit. It represents the square root of -1, the square root of -1. So when we're writing these, the square root of -1 is equivalent to I. Okay, and so whenever we have a negative under the radical, we are going to use I to represent that. Okay, when we go to I squared is -1. So whenever we see an I squared in an equation, we are going to substitute a -1. I to the third power is -I. And I do my I's that little curly so that you know that it's an I and not a 1. And then I to the fourth power is 1. So when we see square root of negative 1, we're going to put in I, but when we see I squared, we're going to put in negative 1. I to the third, we're going to put in negative I, and I to the fourth, we're going to put in 1. So what happens when it's a fifth? I to the fifth starts the pattern back over again. So I to the fifth is equal to I. I to the sixth is equal to negative 1. I to the seventh is equal to negative I to the eighth is equal to negative 1 or positive 1. And then we start the pattern over again. So it's just a pattern that you have to know. Okay. And you should know it. We did it in Algebra 2, A and B. Okay, let's look at some example problems. Simplify, multiply, and divide imaginary numbers. Okay, now I'm going to do a long step on number 1 because I want you to see where it comes from, but most of you don't need to do this. So my first step in number 1 is going to say square root of 9, square root of negative 1, because 9 times negative 1 is negative 9. Everybody knows square root of 9 is 3. And the square root of negative 1, we are using I to represent that. Okay? So I would like for you to simplify number 2. All right, so again, I'm going to show more steps. I'm going to show more steps just to make sure. So we have the regular 5. We have a square root of 12. We have a square root of negative 1. Okay, 5 square root 12 breaks down into square root 4, square root 3. And then our square root negative 1 is I again. Now, I hope that we all know the square root of 4 is 2, and we are multiplying the 5 times the 2. So we have 10 square root 3 I. Okay. Now, some people, alternative way to write this, 10 I square root 3. Some people like that better. But I'm going to write it like the way I wrote the first one. Okay. I most likely will write it like this. Okay. But if you want to use the other one, just know that they are equivalent. Okay. All right, let's talk through a couple more of these examples. Before you multiply these together, we are going to simplify them. So again, this is the last time I'm probably going to show this step. Okay, so take 30 seconds with your partner and figure out what perfect square goes into 75 and what perfect square goes into 108. All right, so let's look at, so 75, you should have 5 square root 3 I, okay? And then 108, you should have 6 square root 3 and then another I. Okay, so now let's talk real quick how to multiply these together. 5 times 6 is 30. Square root 3 times square root 3 is just 3. I times I is I squared. Okay, now 30 times 3 is 90. And remember that I squared is negative 1. So our final answer is negative 90. Okay. All right. I would like for you to see what you can remember on 4, 5, and 6.